Feasibility study consists of four main studies, but one of the most important part is the estimating the demand, which is including the marketing planning. In this video, you are going to learn how you can estimate the demand for your own project. So, is it important to understand the demand forecasting? Is it good to estimate it? What are the patterns that we need to learn? We need to look for the time series. If you have a certain observation for a certain product, which means you have a competitors that you gather data about his production, actual data. Let's say that we have this data in different forms. What kind of patterns that we can see? It can be horizontal, it means it can be a trend, which means it can be seasonal, which means cyclical, which means random, which means what? Which means that horizontal means that the fluctuation of the data is within certain range, the maximum and the minimum. This is called horizontal fluctuation, which is up and down across the five, which is the mean. Assume that the mean is 5, so it is fluctuating either above the 5 or below the 5. This is the meaning of fluctuating of data around a constant mean. The second type, which is the trend. What do you mean by the trend? The trend means either the data that you gathered before is increasing in time, so this is called a positive trend, or vice versa, that the product was highly demanded and then it started to drop, which is decreasing trend. Another type of pattern they can see from your gathering, it is called seasonal. The seasonal means repeatable pattern of increase and decrease. Maybe it can be in summer, winter, ups and downs, this fluctuation that they are highly affected by the season. Then comes the fourth one, which is the less predictable. Less predictable, why? Because it is due to cyclical. What do you mean by cyclical? That through time, sometimes we have recession, the production drops, and then we have a recovery or expansion. This is called the cyclical. Let's say, for example, before we were using cars, which is not depending on air conditioning, which is declining. But recently, there are people are demanding more cars that is using a air condition. So this is the cycles. It is an ups and downs, and it is normally. The random, it is unforecastable, which is cannot determined. All of a sudden increase and all of a sudden decreases, and this is uncertain demand. So the time series, we have different techniques to estimate the demand for the time series. Let's start by the first one, which is the naive forecast, a time series method whereby the forecast for the next period equal exactly the demand. There is no difference, no difference. I take the data as it is. What happened last year, it will be what will be the next year. We will give you an example in the following slide. The second type is the simple moving average. A time series, you gather all the data and then divide it by the number of the recent time periods. So, which is the sum of all the actual demand. The D stands for the demand and the T stands for the time of the period that you are looking for. T minus 1, the previous year. T minus 2, 2 years before, and so on and so on. And then it's the number of observation. So let's see how we can make this estimation. Remember, when you are estimating, you have a forecast. And then this forecast, it is not usually exactly the same to the actual. Sometimes it is up, sometimes it is down, then we will have an error. How we can calculate the error? The error is the difference between the actual and the forecast. This is called the error. How we can find the error? Get the actual demand and then subtract it from the forecasted one. Let's see how we can interpret this. I will give you here a data for a medical clinic patient, and they are having actual demand for the previous 4 week. So in the previous 4 week, we have a 470, 550 patients, 650 patients, 700 patients. And you are trying to estimate what's going to happen in the 5th week. So you have two techniques, you can apply them here. The naive and the simple average technique to find week 5, which means that I will estimate using the naive approach. So the naive means that the actual data, which is week 4, which is the 700, it will be exactly the forecasted for week 5. So, which means that what happened in week 4, it will be exactly to week 5. That's it. Without any thinking, no extra effort, not taking in consideration anything. What about the simple average? The simple average says that you have to gather all the data and then what are the data? The actual data, the 4 that you have it here, divided by the number of observation. And then it will be 593. This is called the simple average. Okay, this is forecast. Imagine that you have been given a demand for week 5, actual demand, and this has happened. And the total number of patient or units or tons and whatsoever is 650. If there is an error, yes, there is. Because if using the naive means that you are estimating 700, but the actual comes 650, which means that you have here minus 50. What do you mean? I was overestimating. I was expecting 700 and only 650 comes. So I was overestimating. So if you use the naive in this case, it will be overestimating. So what about the simple average? The simple average forecasting tell me it is 593. So what is the error here? 650 minus 593, it will give us 57. Oops, it is positive. What do you mean by this positive? I was underestimating. The average technique means that taking all the 4 observation divided the number of the weeks, which is 4, it will give you 593. So this 593 means I was expecting 593% to come, but what actually comes more. So I was underestimating. Great. So now you know the difference between the naive and the simple average. Let's go the third techniques. So if you want to go for the third techniques, and I want to make an recap before moving to the moving average. What do you mean by moving average? The data here are moving by time, which means I can take the last 3 weeks, the last 4 weeks. So here, if I'm asking you, compute the 3 moving average taking in consideration the given data. And the medical clinic here is expecting how much of patient in the 4th week. So given this actual data for the previous, then you are expected to calculate what's going to happen in the week 4, taking in consideration that if the actual which is giving 415, so what you will have an error. Do we have an error here? We need to answer this question. Think about it. So based on this data, then we will find that the solution is depending on, I took 400, the data, the 400 and 380 and 411, this is the actual data. And I add as well the given data, which is the 415 in point B. So I will do what? I will estimate first the demand for the 4th week. How can I estimate the demand for the 4th week? So let's see. I took the previous 3 observation, 411 plus 380 plus 400, and then I divided them by 3. So this is will give me 397. This is the first step. So I use the average to find the forecasting. But pay attention here. What actually come to my clinic is 415. What I'm expecting, 397. So what do you think here? There is a difference? Yes, the actual is more than the forecasted. So I was underestimating. I was thinking that only few people are going to come. So here, the error is for this forecasting is 40, which is the difference between the actual and the forecasted, which means that here that I was underestimating the number of patients. Can I do the same for the 400 for the week 5? Let's see. So in week 5, I will take the second, the third, and the fourth. What about the first? No. He said to calculate using moving average for the last 3 weeks. So I will take only the last 3 weeks. What do you mean? I will take the data for the second week, the third, and the fourth, and will give me the 402. Brilliant. But here he didn't ask for the calculation of the forecast. Now you are practiced well for the simple average and the naive approach and the moving average. Let's go for the weighted moving average, which is a very interesting approach and it taking consideration the fluctuation and the time series method and it taking consideration the importance of certain period over other. So here it is depending on the forecasting for FT plus 1 the coming year, which is the weight times the actual demand, the weight and the actual demand for all the given observation. So let's see how we can do this. So I give you a data for May and June and July, 50 and 100 and 200 and 20, sorry. So I have to do the following steps. The first step, I have to find the sum of the observation, which is 50 plus 100 plus 20, it gives me 170. This is the 170. This is the find the sum of the observation. Second step, they have to look for the finding the weight of each observation. What is the weight? So I will take the 50 divided by 170, it gives me 0.294. The 100 divided by the 170 give me 0.588. The 20 divided by 170 it give me 0.118. So the sum of all these weights it will be 1. Great. So let's see, find the weight for each observation and then you had to multiply this weight which you has calculated times the number of units. So the weight times the number of units, it will give me 14.7. The weight times the number of units, it will give me 58.8. The weight times the number of units, it will give me 2.4. So the sum of all the forecasted weights then you have to add them together, it will give you 76. So this is simply, I will use the weight times the actual. So this is the function and this is the calculation and then this is clear for finding the weighted moving average. What do you mean by moving average? If I ask for what else you were expecting for after June, July, August. So what you expected here, it is August. If it is asking you for September, so you are going to take the actual data. So taking in consideration all the actual data. So let's go for the exponential smoothing, which is a more sophisticated moving average method, and it is taking a certain growth rate, which is the alpha. What is this alpha? Alpha means the growth rate of the data itself, or the coefficient that you have it here. And 1 minus alpha, the remainder of the growth rate, it is highly affected by the forecasted calculation. So let's see how we can find this formula and use the exponential smoothing, which is a very sophisticated method, but it is giving you a more accurate way. So taking in consideration that this alpha or the coefficient, since it is a linear relation, it will not exceed the 1. So let's see. If you are being asked to find the given data that you have it here, number of arrivals for the clinic, 400, 380, 411, 415, and then I'm asking to use the exponential smoothing to find week 5. So what you're going to do here, if we are taking in consideration the difference between 415 and the averages of growth here, the average of the growth for all the arrivals, it is alpha, which is giving here, it is given here, but you can't calculate it because if you want to calculate the growth, let's say for example, so the growth is 415 minus 411 divided by 411, it will give you almost 1%. So it's just 1% increase, 0.01 if I want to calculate the growth rates here. So calculating using the given alpha, so I will use the formula which is alpha actual demand plus 1 plus minus alpha for the forecasted. So let's say, for example, that what is missing here, that the forecast for F3. Where is F3? Taking in consideration that all these are the actual, the 400, the 380, the 411, all are actual. But I missed the forecast for the 30, which is easy because I can get the 400 and 380. I cannot take the third because I'm calculating the forecasting for the third week. So I will take the previous two observation and then it will give me 390. So that's it. So then it is easy to substitute in the equation. How? The alpha, which is giving 0.1, the d, which is the dt. Here dt means f4, and dt here d3. Where is d3? This is the d3, 411 plus 0.90 times 390 that I have just calculated. Then the forecasting is 392. So if let's say, for example, if the forecast is 415, do we have an error? Yes. So the difference here is 415 actual, and I was underestimating because who come to the clinic are 415 patient, but what I am expecting is 392. So I was underestimating the calculation. Can I do the same for the forecast for week 5? Yes, you can do it by using the same approach and finding the 394. Sure, you have to approximate it because we will have a whole number here. So after we did the exponential smoothing, and you can calculate the whatsoever giving data for you, and just use the formula alpha minus zero point 0.2, which is the giving data. Either the two formulas will giving you the same techniques. So here the 783, which is the F4, which is the actual, and this is the growth rate or the coefficient that has been given, time taking in consideration difference than the forecasted for week for month 5 is 784. And I can do the same for D5, which is 805. What is the forecast for month 6? I will substitute using the same formula, then it will give me 789. So it is easy in exponential smoothing because it depends basically on the alpha, and the alpha is giving here. After the exponential smoothing, let's come to the important part, which is average consumption per capita. General economic indicator, which is related to the product itself, such as I need to know the population, remember the data and the gathering, the primary and secondary. Yes, so the population here, it represents what? It represents the secondary data. Per capita income, secondary data. Annual growth rate, secondary data. Income distribution, all of these are secondary data. Great. So we have to look for the present level of imports and the volume and the value, secondary data. Production and importations and substitute, secondary data. Critical input, secondary data. Production target determinations of all these economic variables, they are all secondary data. But what is the behavioral? What are the responses? This is what we call it primary data. So the average consumption per capita is depending on the actual consumption or the consumed product due to the actual production here that available, plus the imports minus the export divided the target population. So I need to find this giving data in order to make an assumption to find the average consumption per capita. So let's see in this data, you have been gathering information of a certain product, the total consumption of a certain product, which is T 250K, and the total export are 100K, and the importation is 50K. So the total population in this place is simply 150K person, and the target population is 50%. So, so I will not take all the 150, I will take only 50% from the 150. Given the growth rate, which is the secondary data that you calculated or find it from the CapMass or any international any statistics that can give you the insight of the growth rate in this place. So using the previous formula, average consumption per capita, actual consumption plus import minus export. Why plus import? Because it is inside the country. Why minus export? Because it exported divided by the target population. So let's see here, it is 250, which is the consumption that used to be consumed in the previous year, plus 50, which is the imported product, minus 100K, which is the export that it has been got out of the country, divided by the target population. The total population, not all the total population are taking my product. They are only 50%. So the ACP means that almost 3 units has been consumed from each person, which means the 200 that I have calculated, 250 plus 50, 300 minus 100, then it will give me 200,000 divided by 75K, which is giving you approximately 3 units per person. So this is easy because the ACP it is 2.66 and the target population, which is now 50% of this 150, it is 75K. Time the gross rate, the new population here, it's growing because it is going to grow by 2%. So the new demand by the multiplication of the ACP times the target population, it will give you 204K units. So this is the new demand for the coming year, which is 204K. This is the new demand for your own project. Brilliant. So if I take this demand and can make a forecasting for whatsoever happen. Let's see another example. Given another historical data for total consumption for a certain product, for tea, let's say, and you are having here 500K units, no export and imports. So this product, there is no export and import, no trade in it, only local product. And the population here is 350%, secondary data. And the target population is 40%. Not all the 350 are consuming this product based on, this is what we call it, primary data, that only 40% is consuming this product. So this is what represent 40% from the 350. Giving the growth rate of a population, which is have been given from the national statistics, which is 3%, and the consumption of the people is increasing due to the increase of population by 2%, then we can find the estimated for this demand. So the ACP means by formula, actual consumption given 500K, but no export and imports, then we have to put the zero. Target population, 40% from the 350, then it would be 140K. So the average consumption will be for each person here is 3.57. So 3.57 it is the average consumption per capita. So this is nice because I can find the new demand, which is the 3.57 times the growth rate, 1 plus 2%, which is 3.64. Target population is going to grow by 3%, 144,200. Then multiplying the target population times the new ACP, it will give me the new demand, which is 425 and 90 units. So this is the demand. Do I have only one product or I have differentiated product? So it depends on the level of scenarios of risk. If the project is risky, then we will be very careful in our estimate. So we will estimate that the common scenario, it will be in the best case 100%. What do you mean by 100? That all what I produced is consumed. All what I provide to the market has been sold. What happens if it is 50%? That only 50% from what I produced has been sold. And the worst one, which is 25%. And it can be average for me. So it is the worst one, it is 25%. So if it is not risky, then you will have the best case is 100, the average is 80, and the worst case it range between 60 and 70. So let's see what we can do if you are going to estimate the demand for the coming 3 years. So a last example to practice more production here is 3,000 unit, and this is for the benchmark and the consumption method to estimate the demand for the 3 scenarios, and you are having only 1,500% consuming the product, and the growth rate of the average consumption is 2%. And here I put my assumption, which is 2%, and the demand forecasting for this coming 3 scenarios for the company is to produce two products. The first product is 10%, the second one is 90%, and the project is not risky. So here, let's take this data and do the planning stage for my project. So the average consumption is the total units produced here, which is the 3,000, divided by the population that they are buying the product. Already here I have been given the target population, so the average consumption is 2. So if the average consumption per person is going to grow by 2%, then it will be 2.04. By the way, the target population is growing as well by 2%, which is 1,530. So this 1,530, it will be my targeted population. And this is the average consumption per capita. And I will take the growth rate, then it will be 2.04. So the new demand will be 3,121. This is the best case. And the best case is going to be divided into two products. 10% for a product A and 90% for a product B. So I take the 3,121 times 10% give me 312. And the remainder will be for the second product. So this is, I have two products only for my project. This is in the best case, what I produced has been sold. I'm working at perfect customized equilibrium situation. But what happened if it is the average scenario? That I have this full capacity, but only what have been sold is 2,497. 10% for product A and 90% for product B. If it is the worst case, which means that only 60% from the 3,121 has been sold, so I have an excess of the product. What will be the scenario in this case for the profitability and for the profit ratios? Is it going to be profitable or not? After doing all the visibility study has been completed and presented to the leaders of the project, they should carefully study and analyze the conclusion and underlying assumption. Next, they will decide which course of action to pursue, the business plan or not. How to do a business plan, see our next video. Thank you for watching. If you will enjoy and get benefit from this recording, do not forget to subscribe. Best of success. Thank you.